So to interpret these and to solve these, we just need to understand that when we're looking at the square root of some number, like 5, right, in example 1, square root of 5 is really asking us to find the side lengths of a square that has an area of 5. Now here's the thing about a square, right, is the side lengths are all equal. So I've just got to figure out the side length by figuring out what number multiplied by itself would be 5 in this case. Now that's going to be kind of hard to figure out because 5 is not a perfect square. So what this means is that we'll need to estimate this probably to the nearest hundredth, which is what it wants. And the interpretation then is, I'm just going to write x squared equals 5 in this case. So what numbers is it between? Let's take a look at that. Particularly perfect squares are things that we need to know, so it may be helpful to memorize at least the first 12 perfect squares. What this means is I'm going to take the first 12 numbers and just square them. So there I have them. Let's go and square them. And we should get these values. Now why do we need these? Well, it's going to help us, particularly with this next part. The square root of 5, okay, now this means that this list, if we took the square roots of these numbers, we'd get these ones, okay? So the square root of 5 is between the square root of 4 and 9. So that means that the square root of 5 is between 2 and 3. Now we can round this by punching it into our calculator. Square root of 5 for me, I got 2.2 rounding to the hundredth, 2.24. Now let's look at number 3, 65. Square root of 65 would be the same as some number squared equals 65. So 65 would be between 64 and 81, which means it's actually between the numbers 8 and 9, the square root of it. So it's between the numbers 8 and 9. And again, estimation, I just take the square root of 65, which is 8.06. So let's move into these other ones. Let's look at 6 through 14 first, just a few of these at least. 6 has the square root of 49. So I'm looking at my perfect squares, and I can see 49 is right there. So the square root of 49 is 7, meaning 7 times 7 is 49. Or again, if we had a square with an area of 49, the side lengths would be 7. 121 as well is on the list. That's 11 squared. 4 is 2 squared. Now these other ones that I just barely put up there, they're all on that list of perfect squares, which is why I have them. But what I really want to do here is look at some of these that have negatives. So number 11, for example, this is the negative square root of 100. So I'm just going to take the negative, and the square root of 100 is 10, which again I can find from the list. 14 is going to work the same way. It's negative, and the square root of 289, I believe, is 17. 13, though, is different. It's the square root of negative 100, which means that I would have a square with an area of negative 100. So what two numbers multiply together to give us negative 100? Now they have to be the same number. Well, 10 times 10 is just 100. And negative 10 times negative 10 is still 100. So the problem is that we can't multiply two numbers that are the same. That would give us negative 100, which means that this one is just not a real number. It's not a real number. So what does that mean? Well, that means that on 19, just like on 13, with the negative on the inside of that radical or the square root, that means that the answer is not a real number. Let's look at some of these other ones with fractions, okay? We got 15, which is the square root of 25 over 81. As it turns out, we can just take the square root of the numerator, 25, and the square root of the denominator, 81, and just separate these. And the reason why this is nice is because these are all going to be perfect squares. The square root of 25 is 5. The square root of 81 is 9. And that would be our answer right there. 17, square root of 16 is 4. Square root of 9 is 3. Improper fraction, that's okay. 16, square root of 1 is 1. Square root of 144 is 12. There we go. Square root of 4 is 2. Square root of 25 is 5. Nailed that one. And finally, this is just going to be the negative. Square root of 1 is 1. Square root of 100 is 10. There we go. Now these ones all worked out pretty nice, but here's the thing, is that in the future, in some of your future classes anyways, they won't always be that way, and that's okay. They're you'll see different ways to simplify these or to change them into decimals, even if you are using a calculator, but we don't need these to be particularly perfect squares. So 4.7b, this one is looking at simplifying these square roots. Now we want exact values, which means we're not just going to use a calculator to estimate these. And here's what we mean by that. So there's two ways that we can look at it. We can split 27 up using a factor tree. So that would be 3 and 9. And 9 splits up into 3 and 3. So this ends up really being the square root of 27. If we break it up, it's going to be 3 times 3 times 3. Well, in order to pull something out of the radical or the square root, I've got to find two numbers that are the same, because those would be like the side lengths of that square being multiplied together. Well, that means I've got a 3, and then I've still got this 3 left over, but it didn't have anything to pair with, so it remains in the square root. So that's 3 times the square root of 3. Another way we could have looked at this is by taking the square root of 27, and we could have stopped at this branch because we can see that one of these is a perfect square, which means that you really have the square root of 3 times 9. Let's switch those around actually and make that 9 times 3. See, and we can break this up into the square root of 9 times the square root of 3. Well, what is the square root of 9? It's 3, and the square root of 3 is still just the square root of 3. So we can see that the answer is the same either way that we look at it, like this. So 3 will do the same. We'll just do this the same way. I prefer to look for the pairs, but if you like looking for those perfect squares, that's okay too. It just takes some intuition sometimes, okay? So 18 is going to split up into 2 and 9. Again, there's that perfect square, right? 9 splits up into 3 and 3. So 18 is the square root of 3 times 3 times 2. Well, I found my pair of 3's to take out of that square root, and I have the 2 remaining inside. So this would be my final answer. Let's try 5, but let's do this using perfect squares. And this may show some problems with this because it depends on how we split this up, just to start out with, okay? For example, 72, some people may be thinking of 8, and 9, right? Well, 9 is a perfect square, so we know that it's at least going to be 3, but here's the problem, is that 8 splits up into another perfect square right here with the 4. And 4 would come out, the square root of 4 is 2. See, and then we've got this 2 that's still remaining on the inside right here, so we'll start to multiply this by the square root of 2. So what do? Well, we got to multiply the 3 and the 2, which is 6. And then we still got that square root of 2, which is what the answer is. So if we had split this up, we may just be looking for pairs, which would have pulled out the 3 and the 2 and then multiply. But again, we just have to be careful with that, because if we left it as 3 times the square root of 8, we wouldn't have taken it far enough, and we would have lost points on that. So just be careful if you do it that way. And how about the negative square root of 76? All this means is that our answer is going to be negative. So we'll just keep that there. Let's just break 76 up then. So I see it's even. I can break it up into 2, and that would be 38. And then this splits up into 2 and 19, which is prime. So we got 2, 2, and 19 is the negative square root. That didn't come out very well. Square root of 2 times 2 times 19. And I got a pair of 2's, which I can pull out. So I'd have negative 2, not forgetting the negative, right? And I got the square root of 19. There it is. So what do we do if it already looks like it's simplified? Well, we just need to check and make sure. 28 needs to split up into 2 and 14 maybe, which splits up into 2 and 7. So that gives me all my primes. So this is really 4 times the square root of 2 times 2 times 7. And yes, I've got a pair of 2's that I can pull out. So there's my 2, but I still have the 4 to multiply that by, and the square root of 7. Well, 4 times 2 is 8, and then I got the square root of 7. This would be it. It's my final answer. 12 will work the same way. Let's look at 58. Split this up into 2 and 29. 2 is prime, but 29 is prime as well. So, as it turns out, this one cannot be simplified. Or that we would say it's already simplified.